Hello, welcome to Module 5, where we will be introducing the Arduino programming language. So, what is an Arduino programming language? Arduino programming um, files are usually referred to as sketches and are based uh, on C, um, language. So, we have structures, data types, class definitions, and program control and operations, which are similar to C, C++. And also the Arduino language is based on another language called wiring, which builds upon processing. And the structure of an Arduino sketch is very similar to processing, where it contains every sketch contains two major components, a setup and a loop. So later on we will see um, how we can program uh, different functions in the setup and loop. The compilation process, when you write code in programming Arduino language, is that a C compiler is evoked, which with the help of AVR libraries are compiled to create hex codes, which are then pushed into the Arduino hardware. So the Arduino programming language has a set of built-in standard core libraries or functions. So we have digital and analog input-output libraries, serial communication libraries, time functions, interrupt functions. So these are all available in core libraries or core functions. So you also have other libraries which are available. Some of them are supported by the Arduino developers, and some of them are third-party libraries. So those libraries are used to control motors, read and write to EEPROM or RAM, um, you know, software implementation of serial protocols or PWMs, pulse width modulated signals, and also sometimes controlling of LED matrices and the more advanced libraries which take care of some advanced protocol, both wired and wireless. So before we go into and understand the basics of the language, a few um, brief look at the terminologies involved. So as I said, the program which you write for an Arduino board is generally referred to as a sketch. Then we have a pin, which is nothing but an input and an output uh, connection to the microcontroller. So a pin could be an output of an LED or input from a potentiometer or a knob. You also have digital value is either high or low, so that's either a 0 or a 5 volts, and an analog value uh, in Arduino means that it has a value ranging from 0 to 255, and so we can actually use an analog output to adjust the brightness of an LED or control the speed of the motor. The Arduino language, as we said, is pretty much similar to C, C++, but much easier than C, C++. So there's a lot of functions um, which are used to control the hardware. So some of the functions are like pin mode, which sets a particular pin of that microcontroller in the Arduino hardware to being an input or an output. Then we have, if we want to write a high or a low value to a particular pin, then we can use the function digital write. If you want to read if a particular pin contains a high or a low value, you can use a digital read. Similarly, you can use an analog read to read an analog signal, and an analog write to write an analog value. So when you write an analog value, you write a value from 0 to 255. So, and then you also have some standard functions like delay, and the the arguments you give in your delay is usually in milliseconds. So if I give a delay of, in brackets, 1000, so it means that I'm expecting it to have a delay of 1 second. So you can also get some current time or system times by using the function millis. So a typical Arduino programming example, uh, as you can see, is specified here. And so first we try to specify, um, you know, uh, as you can see, we try to specify uh, a setup module and then a loop module. So the setup module gets executed once, and the loop module will get executed uh, pretty much forever. So here an application is simply we want to, this is a light emitting diode, and this is the Arduino hardware, and as you can see that this header gives you access to the microcontroller's pins. So one of the pin is ground and one of the pin is connected to pin number 13 of the microcontroller, and we want this LED to blink at a particular rate. So in order to implement this very simple design, uh, as you can see, we first define uh, where our LED is connected. So we can see that the LED, we define a variable called LED pin, and we say it is equal to 13. So which is nothing but that the 13th pin is containing an LED. So the setup function defines the pin mode. So we want to, since we are going to output a 1 and a 0, to turn on and off the LED respectively. So we are going to use that as an output. So therefore we need to make sure that this pin number 13 is an output. So next we go on to our loop function. The loop function will be executed indefinitely. So therefore we're going to use the digital write. So pin number 13 is going to be given a value which is high or 5 volts, so that the LED will be turned on, and you call in for a delay of 1 second. And once the delay of 1 second is being completed, so then we give a digital write again to pin number 13 with a value low, so the LED is going to be turned off, and then again call for a delay of 1 second, and then it goes back here, it turns on the LED, waits for 1 second, turns it off, waits for 1 second, goes back on and turns on the LED, waits for 1 second, turns off the LED, waits for 1 second, then turns it on, off, on, off. And this, by this, it just keeps on repeating, and so you will see that the LED blinks. So it goes on, off, it is blinking. So as we said earlier, whenever we write in Arduino programming language, we pretty much write a sketch, and the sketch is an extension called PDE. So in your Arduino IDE, where you write your sketch, it gets internally converted into a C++ code, and this C++ code is cross-compiled with an AVR cross compiler, C compiler, which is called AVR GCC, to create object codes. And once you get these object codes, and these object codes are linked together to create an executable file for the microcontroller, which we call it as a hex file, and we refer that as a bytecode. So we get it as a bytecode, and then we use an AVR dude, which is a AVR programmer, to burn that hex code into your microcontroller's program memory. So these are the steps which are involved in from writing a sketch to pushing it into the Arduino hardware. And this entire process is done by a click of few buttons using the Arduino IDE. So we have already covered the process of installation of the Arduino IDE and the process of compilation and download of a particular sketch to an Arduino IDE. So whenever we start to develop an application, we generally start from schematics. So schematics is nothing but something like a wiring diagram which specifies how the components of a particular application are connected to the microcontroller or to any processor or any particular IC. So in this case, as you can see, this is our different input output pins of our microcontroller or our Arduino hardware, and there are a bunch of digital as well as analog inputs and outputs. So in our particular application, we are going to have a switch which controls the turning on and off of a particular light emitting diode. So whenever the switch is held on, the LED will glow, and once you release the switch, the LED turns off. So therefore we're going to use a push button switch here and an LED light emitting diode there. So as you can see in the schematics, so we can see that we are using pin number 13 of our hardware to connect to the positive end of the LED, and the negative end of the LED is grounded. So by driving a high signal here, the current flows through it, through our LED, and thereby the LED turns on, and you have the circuit completed. And again, you can see that we are going to also monitor uh, the condition of this button using a pin number 2, which is a digital input. So when the switch is turned on, so the value in 2 is read as a low, and or sorry, is read as a high, and based on that the LED here gets turned on. So we can also specify our schematic as something similar to what is shown here. So you can see here we are actually now connecting the switch, which is a push button switch, onto pin number 2. So this is your actual Arduino board, and then the LED is connected to pin number 13. So this layout is also shows a two-dimensional view of the connection from the Arduino to a breadboard. So as you can see that the symbol for the LED is given as that. So, and it's actually as you can see, the LED has one side flat and the curvature on all the other sides. The flat side is generally referred to as a cathode, and the opposite side is referred to as the anode. So in order to make this LED glow, so you need to give a high value at the anode and a low value or zero value at the cathode, and that will make the LED glow. So as you can see, here is the translation which happens from our schematic to the breadboard. So as you can see, this is our push button in the schematic, and this is our push button in your actual implementation. And this is again a resistor which limits the current which is flowing through the switch. So that is actually shown here in your layout for the Arduino or the application. So in some cases, as we mentioned earlier, instead of using a breadboard and connecting individual components, we tend to use sensors with these adapters or buckle adapters and these are called as bricks. So these bricks are now interfaced to your shields, Arduino shields, by using a buckle cable. So as you can see now, this represents the LED and this is your push button switch. So application here is when the button is pressed, the LED should turn on, and when the button is released, the LED turns off. And so this is a very simple example of a digital input output application. So in our case, you can see that's our real um, hardware setup. Again, the LED light emitting diode and a push button, and our digital input and output are connected to the different types of buckles in our Arduino shield, and we can actually now see a demo. So we have actually compiled and uploaded the program which we just saw earlier onto the Arduino hardware. So now we will actually see the demo of how um, the application performs. So you can see that by pressing the LED, by pressing the push button, the LED is turned on and off.